Hello everybody, I am Sudnani, Assistant Professor, Department of Civil Engineering, KJ Reddy College. In the one of the class, we discussed about the types of the flows. In today's class, we will be discussing about the continuity equation. The continuity equation, it depends upon the flows. It means the water flows from one section to another section when you consider the conduit section. The conduit section means pipe. It might be pipe or any types of the different types of the pipes also. If the water flowing from one section to other section, and how it will be the velocity and discharge and the flow rate changes. So that's we describe by using the continuity equation. The continuity equation, what does it mean exactly? It means it related to the law of mass of conservation. Law of mass of conservation. As you might be knowing about the law of mass of conservation, what it says, the whatever the mass which enters into the pipe, it should be equal to the mass, that is the liquid mass exits from the, this is the pipe, consider a one section, this is the section 1, consider and one more section, this is the section 2. Here I will explain law of mass of conservation. Whatever the liquid enters into this pipe section, it should be equal to the outlet volume of the liquid. For example, the water enters into this, it will be the mass M1. Okay, when it enters into the pipe, the mass will be M1. When it come out through the outlet of the section 2, that is mass M2. According to law of mass of conservation, what it said, it should be equal. It should be equal, that is M1 is equal to M2. Just consider at the section, the rate at the section, the flow rate at the section, at section 1. So, the rate at here is density of the liquid and area of this will be, so rho 1, why I am giving the rho 1, it may change also. So give like a rho 1 as it is same. The whatever the liquid enters into the first inlet, it will be always same the liquid at the section 2. So and velocity V1. This is at section 1, and at section 2, that is rho 1, A2 and V2. This is the flow rate, at section 2 is rho 1, A2, V2. You can ask why rho 1, because whatever the liquid enters into the pipe, the same liquid should come out. So same liquid. So I taken rho 1, or else you can take as a rho 2. It should be equal. According to law of mass of conservation, what it says, it should be equal. So rho 1 A1 V1 is equal to rho 1 A2 V2, or how to write it, rho A1 V1 is equal to rho A2 V2. It should be equal. So what continuity equation says, it should be the whatever the enters, the flow rate should be equal to this. So now if it is a compressible or incompressible, so if it is incompressible fluid, incompressible, what it says incompressible, one of my video I explained about the properties of the liquids, that is incompressibility or compressibility. For example, water. 1 liter capacity of the bottle which contains maximum only 1 liter, no more than that, because the water is incompressible. So, if it is incompressible, then what the condition says that with respect to density? So, the density will be equal, it means it is a constant, cannot change. So, what it says the equation, A1 V1 is equal to A2 V2. This is the continuity equation. So, it ends here. We will solve one of the example over this. Here I mention one of the example. This is a very easy example. Just will read this. The diameter of the pipe at section 1 and 2. The section 1 and 2 are 10 centimeter and 15 centimeter respectively. What they mentioned here? Diameter. So, take the diameter, this is the solution. Diameter at the section 1 is D1, that is 10 centimeter. And diameter of the section 2 is D2, will take, that is 15 centimeter. Find the discharge through the pipe. What they asked? They ask discharge through the pipe. If the velocity of the water flowing through the pipe at section 1, the velocity at the section 1 they given is, the pipe at the section 1 is 5 meter per second. Determine the velocity at the section 2. They asked velocity at the section 2. This is the given problem. As you can observe here, D1 is less than the D2. It means here is the lower. You can observe here, this diameter is the lower. How it's the gradually increased and reached the some one point, that is just consider 15 centimeters. So, the same figure will be applicable for here also. Now, what they in the problem itself they mentioned the water. The water it is, this is incompressible fluid. So, we have to use this equation. Now, the solution comes here. Equation is A1 V1 is equal to A2 V2. Whether we know A1 A2, we don't know. A1 is equal to pi d square by 4. So, pi as it is into d1. So, that is 10 centimeter, in terms of meter is 0.1 square divided by 4. And A2 is also same, pi d square, that is the 0.15 square divided by 4. Just calculate this, the simple calculation, we will solve this. The first one is pi 0.1 square divided by 4. So, we got answer is 0.0078. I hope all of you got the same answer. Now, what is the unit for this? We converted into meter. So, this is the area, meter square. Now, the second, the A2 is 0.15 square divided by 4. That is 0.017 meter square. A1 we got, A2 also we got. A1 we know, A2 know, and V1 we know. Only unknown term is V2. So, we can find V2 here. So, the A1 is A1 V1 is equal to, so A2 V2. We need V2. what they ask? V2. So, V2 is equal to A1 V1 divided by A2. So, same, just substitute all the values in the equation. A1 is 0.0078 and V1 is 5. Same, this unit is in meter only, so no need to translate. And A2 is 0.017. So, now we will calculate 0.0078 into 5 divided by 0.017. So, we got the V2 is 2.29. What is this unit? All is in meter. So, meter for second. The one more they asked is about, can you read? Find the discharge through the pipe. So, what is discharge? The discharge through the pipe if the velocity after flowing through the section 1. So, Q they ask, Q is equal to A1 V1. This is the discharge, area into velocity. So, area of the section at the section 1 we know that is 0.0078 into V1 we already they given, that is 5. So, just calculate this, you will be getting 0.078 into 5, that is 0.039. What is the unit? This is meter square and this is meter for second. So, meter cube by second, this is the discharge. You can find the similarly discharge, they did not ask, they asked the discharge at only when you the water enters into pipe. So, you can calculate the discharge with respect to V2 also. So, what they asked, that's to find the discharge also we found, and they asked to determine the velocity at section 2 to the V2 also we got. This is the continuity equation. They may ask the questions like they may give the different types of the sections of the pipe. Here this is the very simple, they may give the pipe sections like this also. So, in that situation the taking the sections are very important and the same equation will be carrying to the same. So, no any difference, the only simple equations are how to follow. The things we remember in this concept is about, this is the law of mass of conservation. When they ask about the continuity equation, we should mention this law of mass of conservation. Okay, and this is the simple derivation, and you have to mention flow direction and section 1, section 2. That's it. Okay, then the mass means rho 1 A1 V1, and this is for the incompressible flow, this will be equal. So, just ignore that A1 V1 is equal to A2 V2. In some of the problems, they may displace this liquid, they may give oil, the oil density will be different. So, you have to take, but the oil, water, whatever they may give, whether that is the compressible fluid or incompressible fluid, they may give compressible also. That time you have to take rho 1 and rho 2 separately, because if they give at when the incompressible, the density gets changes when enters, and for example, the LPG if you take, that is the compressible fluid, the density may get deforced. So, you have to take rho 1, rho 2. But this almost all, if they give water, liquids, oils like this, then that will be always the incompressible. So, you can take this equation simply. Okay, I hope you all understood. If you are having some of the doubts related to some of the problems related to this, just approach me, we will solve in the easy mode. I hope you understood. Have a good day. See you.